So continuing with our review of factoring, we are in this video still factoring ax squared plus bx plus c, but we are going to learn a different method that's an alternative to guess and check. So this one, I'm sure different teachers have called it different names, but I have heard it termed slide, divide, bottoms up. Now, this is an alternative to guess and check. If you are a super proficient guess and checker, you need to practice this, but when you are doing your exit tickets, when you're taking your quizzes or tests, you will get to choose the method that you want for factoring ax squared plus bx plus c. So it's a split. I would say that people who know their factors and have really great number sense usually like the guess and check method. People who kind of like the tricks, like the slide, divide bottoms up method best. If you want to rotate between them, then that's what you can do. You get to choose. So the name kind of gives you hints as to what the steps are. So I've written out for slide, divide, and for bottoms up what needs to be done. Now, because this is kind of a trick method, reading it isn't going to make sense without actually looking at it in a problem. So I won't read through these steps until we go through them here together. Just like always, remember that factoring order of operations should apply every time it tells you to factor. You start with GCF, then check for special products, then see if it should be chart factored or if it should be factored this way. So I look at these, and there is a common factor here. All three of these are divisible by 3. So I need to take the GCF of 3 out first. Leaves me 2x squared plus 11x plus 5. So I've got the GCF out. What is left is not a special product because 5 and 2 aren't perfect squares, and it definitely can't be chart factored because there's a number in front of the x squared. So instead of guessing and checking, we can do slide, divide, bottoms up. So the way that we do that, slide means that we are going to slide a down off the x squared and multiply it with c to create a new constant. So we take 2 and we slide it down to multiply with 5. So this 3 is still out in front here, but we're going to now make this x squared plus 11x plus 10. So we've created a new constant. Once we do that, we're still in the slide step. We then can chart factor with winning numbers. So look for what multiplies to 10 and adds to 11. So that one's pretty easy. 10 and 1 are my winning numbers. So just like regular chart factoring, it says chart factor. So I'm going to chart factor x plus 10 times x plus 1. So I did that. I filled them into the parentheses. I'm done with the slide. The divide says divide the constants in parentheses by your original A. Now be careful. When we mean original A, we mean before, and maybe we should write this. Before sliding. It doesn't mean the very original problem. Because in the original problem, A is 6. But before I did the slide, A was 2. And that's what I want to use in this case. It says divide the constants in the parentheses by that A. So I'm going to divide the constant here by my 2. Divide this constant here by my 2. And then it says simplify the fractions. So 10 over 2 simplifies to 5. 1 over 2 does not simplify, so it's in simplest form. Final step, so I did the divide step, now I do the bottoms up step. Bottoms up means to take any denominators that didn't cancel in the simplifying, so that would be this guy, and bump it up just in front of that x. So not in front of this one, but just this guy goes here, bottoms up. So that's 3 times x plus 5 times 2x plus 1. Remember that you can always check with every type of factoring to make sure it works. So if I multiply or FOIL this x plus 5 times 2x plus 1, insides give me 10, outsides give me 1, so that's 11, which would work. So this is my final answer. All right, let's try another. Looking at B, there is no GCF, 17's prime, so I know there's nothing I can do there. It's not a special product. 12 and 6 aren't perfect squares. So I'm ready to start my slide divide. So in this case, I am going to start with sliding the 6 down to multiply with the 12. So now it's going to be a plain x squared instead of a 6x squared. So that becomes x squared minus 17x plus 72. Then I'm going to chart factor it. So here I'm looking for what multiplies to 72 and adds to negative 17. So I know it needs to be two negatives. So 72, let's see, -9, -8, I believe are my winners. Yep, and again, if you don't get it on the first try, that's totally fine. Keep listing things that multiply to 72. So here are my winning numbers. So x minus 9, x minus 8. So that's the slide part. Now I need to divide, so divide by my a, which was 6 in this case. And reduce. That's part of dividing, is reducing. These are both divisible by 3, so it becomes 3/2. Over here, these are both divisible by 2, so 4/3. So in this case, they're both fractions, so when I go to bottoms up, this guy comes in front of this x, this guy comes in front of that x. So 2x minus 3 times 3x minus 4. Can double check it. -9 minus 8 gives me negative 17. 2x times 3x gives me 6x squared. -3 times -4 does give me 12. It all works out. This is my final answer. So just like in the previous video, I'd like you to try the last one by yourself. So go ahead, go through the slide divide bottoms up steps and pause the video while you do that. And then when you're all done, come on back, unpause it, and check your answer with mine. Okay, so there is no GCF here. Got a lot of prime numbers. Not a PST, because this is a minus. Oops, didn't mean to circle that one actually with the real pen. So it's not a special product, so I know I need to do either guessing and checking or slide divide, and this time we're doing slide divide. So multiply the 3 times the -5 for my slide, x squared minus 2x minus 15. Then I'm going to chart factor it, so we're looking for what multiplies to -15 and adds to -2. So that would be -5 with +3, because those do multiply to -15 and they add to -2. So x minus 5 times x plus 3 is the end of my slide step. Then I need to divide. So my a was 3, divide by 3, divide by 3, and reduce. 5/3 doesn't reduce, so we leave that. 3/3 reduces to 1. And then I've got 1 to bottoms up. So 3x minus 5 times x plus 1. I can check it, 3x squared for the firsts, so check. Outsides are +3, insides are -5, which gives me -2, and then lasts are -5. So I mentally foiled it, it works, and so I've got mine completely factored. Hopefully you got it right too.